Hello, everybody from WCA Physics. This is Miss Peachy, and today I'm going to walk you through what to do for your kinematics portfolio in Lesson 7. Um, so for this portfolio, you're going to be doing like a tabletop kind of simulation where you are going to be determining or predicting the distance that a projectile is going to be launched from horizontal. So you're going to apply the equations that you've been using. I do have let's just see if I can find it over here, a template that I would like you to use to submit your work to me. So in this template, you are going to write down the purpose. Why are you doing the experiment? Make sure in this that you are going to tell me what physics in principle or what principles in physics you are actually learning and what you're investigating in here. And then I just kind of added to this because you're also going to then be in the next section describing your experiment and then making predictions. So you may have to come back to this a little bit after you've taken some initial data, just so you know. You may have to come back to making a prediction before you finish the experiment, but like after you kind of start it. So I'll get to that in just a moment. So basically, you're going to describe the experimental setup. Don't copy and paste from the lesson. In your own words, I want you to describe how you set this up, and then also describe, any of the things you're testing, any of the variables you're testing, and what kind of data you will be collecting in that experiment that you're performing. You're also going to include any predictions that you'll be making. And again, you won't be able to make those predictions right away, but I'll tell you when you'll need to make those predictions in just a moment. In the next section, you will be including two data tables. Both of those are found on slide 4. For this portfolio, there will be no graphs. In the next section, you are going to make calculations throughout here. You're going to be calculating the velocity of your marble. You're going to be calculating the you're going to be measuring and calculating the final distance that the marble goes. So you'll calculate it first, and then you'll measure it, and then you'll compare those two together. And so I want you to put those calculations in this section, like all of your work, so I can see that. And then finally, in your conclusion section, you are going to also write out the questions that are found on slide 4, questions 7 through 9, and on slide 5, questions 1 to 2, and the answers after those questions. So I have both questions and answers. Since this is a Google Doc, you can go to File, make a copy, and then you can edit that copy. And once you are done editing your copy, you can actually go to download and download it to your computer as a Microsoft Word file. And then you'll be able to attach that Microsoft Word file to the Dropbox. Or you can just go ahead and download it right away and do your editing in Microsoft Word and save it and upload it to the Dropbox that way. That is up to you, but it does have to be as a Word file when I see it. Okay, so what does your experiment look like? Well, you're going to be setting up a ramp on a table. You can just use some books for your ramp, a marble for your ball, golf ball, something like that. Make sure it is some distance away from the edge of the table, from here to here. You need to measure that distance. So don't make it right at the edge of the table. I suggest making it a foot or so back. And then you need to have enough room so when the ball reaches the edge of the table, it falls down and hits the floor. Make sure you have a second set of eyes. So once you drop that ramp, you also need to mark exactly where it lands. So sometimes that's hard to manipulate on your own. Maybe your brother or sister can drop the ball for you and you can mark where it lands. Okay, so there's multiple ways to do this. If you can do this outside, like in a sandbox or something, you can rake the sand really, really smooth. And when the ball drops, it can actually hit the sand and make an impression. And that's a good way to measure as well. But you don't want to mark where the ball rolled to. You want to mark where it first landed. That's very, very important as well. Okay. So the first thing you're going to be doing is you're going to be measuring the velocity of your ball. So what you need to do is you need to you're going to let it go down the ramp, and then once it reaches this point right here at the edge of the ramp, you start your stopwatch. And then once it finishes here, you stop your stopwatch. Okay? And then you're going to measure the distance. Now remember, velocity is distance divided by time. this should be in meters per second. So if you make this, for example, half a meter, then your math becomes a little bit easier, right? Or for maybe you make it 10 centimeters, which is zero point 0.1 meters, then your math becomes a little bit easier. But make sure you measure this in meters and divide it in seconds so you have that velocity in meters per second. And you're going to do that 3 times and take the average of it so that you have a good measurement, right? So 3 different trials, take the average to get your average velocity. And then you're also going to record the time. Okay, so you got your time in seconds, you're going to calculate your velocity. So that's what you're doing here. 3 different trials. Then what you're going to be measuring is you're going to actually figure out how long is it going to take before it hits the ground. So to do that, we're going to use this formula right here. We're going to take the height of the table in meters is equal to 1/2 negative 9.8 times t squared. Remember that the height of the table in meters is also a negative number because it's falling down. That should be a negative number. So then when you do your square root, you will have a positive number under the square root and not a negative. So just make sure that you remember that as well. So you're going to be calculating the time. So you know how long it's going to take. This is a different time. Before, that time you took was to figure out speed. That's your v sub x, right? That's your velocity in the horizontal direction. Now you're going to figure out your time it would take to hit the ground, from the time it would hit the table edge to when it would hit the ground. Then you're going to calculate the range of your projectile, okay? You're going to calculate this. You're going to make a prediction. How far is it going to go? You're going to need to use this formula to make your prediction. Delta x is equal to v sub naught, which is v sub x, like I said before, times time. You have your average velocity here. That's what this number is right here. You just solved for time, so to calculate your prediction is going to be that velocity, which we did in the first table here, times the time you just calculated. And that's where you're going to go back to here in the procedure, and you're going to make your prediction. That you predict it's according to your calculations that it's going to land this far away from the table. That's a prediction you're going to make. Then you're going to trial. You're going to do it 3 times. You're going to actually let that marble go and hit the ground, and you're going to measure how far away it is. Remember, when you're measuring, you are measuring this distance, not this distance. You're measuring, you go straight down from the table's edge, make a mark, and then you record the measurement from that mark all the way to the mark where the ball fell and hit the ground. That's your delta x here. They call it capital D, but it's called delta x. And that's what you're measuring, is that horizontal distance. You made a prediction, but now you're going to see if your prediction, how close your prediction actually is. So that's your experiment. And then you are going to answer these questions 7, 8, and 9, and then also answer questions 1 and 2. And all of that goes on that template, and that link for the template is on our Student Hub as well. Okay? If you have any questions, let me know, or any concerns. Otherwise, good luck and have fun.